All right, gang, more about standard normal distributions and transitioning these standard normal distributions to a more general, just normal distribution. Now, the example I want to start out with is we know that IQ scores are normally distributed with the mean 100, standard deviation 15. And I will tell you that you'll often see this abbreviated and written as a cap N for the normal distribution. The number that comes first is the mean, and the number that comes second is the standard deviation. So just to make sure there's no misunderstanding, let me grab another sheet of paper here. If you see in 32.5, this tells you, I don't know why that thing is not focusing for me. This tells you that we have a normal distribution with a mean of 32 and a standard deviation of 5. So we have a normal distribution, mean of 100, standard deviation of 15, and this is what the distribution would look like. Now I'm going to tell you, this is going to be a very brief video, but it's going to be one of the most important videos I think that I create and share with you on this topic because it's going to get you started in the right direction. So the first type of problem I want you to think about, what is the area to the right of an IQ of 120? So 120 would be about right here someplace. And we want to know what is the area to the right. And again, from the previous video, we determined that the area is also equivalent to the probability. So saying what is the area to the right of 120 is equivalent to saying what is the probability of selecting someone at random and them having an IQ higher than 120. I don't want that to, I want that to again, sink in the importance of that. The two statements are equivalent. What is, or I should say the two questions. What is the area to the right of 120 in a distribution of IQ scores is equivalent to saying if we select a person at random, what's the probability their IQ is greater than 120? Those are equivalent statements. Now, three ways we could work this problem. So what is the area to the right of an IQ equal 120? The first way we could do it is using the horse and buggy approach. I'm not even going to give it any value using the tables. It's just ridiculous to use tables when you have technology at your disposal now, or at your access. Now, if you're on a deserted island and you have to create z-scores to get off the island, you don't have technology, then go for it with your table. But otherwise, let's just forget that. It's ridiculous. So we create a z-score of 120 over minus 100 divided by 15, we get a z-score of 1.33. From the previous video, we know that z-scores have a mean of 0, standard deviation of 1. So I could put 1.33 in my calculator, as I've demonstrated previously. 0, 1, I need above 1.33. And I get an answer of 0.0092. Now remember that. Which one would I use? Will I use option 1 or option 2? Well, you know how anti-tables I am, so you know I wouldn't use option 1. Would I use option 2? No, I wouldn't. There's an easier way. The calculator doesn't force you to use 0 and 1 as the mean and the standard deviation. You have the flexibility of changing that. And in this distribution of IQ scores, not standard normal distribution that has mean 0, standard deviation 1, in this specific distribution, with a mean of 0, standard deviation of 15, I can find directly the area to the right of 120 just by doing that. I don't need to convert this to z-scores and use those wacky tables. I don't need to convert it to z-scores and use the standard normal distribution. The technology allows me to directly input the problems from the areas I'm trying to calculate specific for that distribution, in this case, normal distribution. Let's look at this one. Now, you're talking about a lot easier. What IQ score has 65% of the area? Let me see if I can, that seems a little unclear. Maybe it's just because I haven't had my second cup of coffee yet. What IQ score has 65% of the area to the left of it? So that's one of those where we find the IQ that has a given proportion to the left or right, right? Option one, use the goofy tables. You know how I feel there. Option number two would be to convert. Oh, okay. Option number two would be this. Go to the z-scores, standard normal. I need the z-score that has 65% to the left. And I can see that's 0.3853, right? So that's a z-score. What I can do next is I can put insert 0.3853 in the z-score formula. Remember, z equal x minus mu over sigma, and put IQ there that I'm trying to find that corresponds to the z-score. Do the algebra. It's not that hard, but I'll find an IQ of 105.78. Which option would I use? The goofy tables, convert the score to a z-score, find the area under the z-score, convert it, use all this. I wouldn't use either one. I wouldn't use either one. I'd use that, 105.78. Directly input the information. Stop converting this stuff to z-scores. You don't need it. If you have a z-score, if you have a standard normal distribution, and you want to find information about a specific z-score or something, then plug it in. But if you have a normal distribution, not a standard normal distribution, StatCrunch allows you to just input it directly. For example, what if we wanted to find for IQs? We wanted to find the two IQ scores that separates the middle 95% of our data. Now, what we could do is what? Well, there's 5% missing, so there's 2.5% down here. There's 2.5% down there. We can go to our goofy table and find the IQ, the z-score, and then convert it to an IQ and all that. Or between the parameters of our model, we know that we want 0.95 between the two values, and click it and be done with the problem. 70.6 to 129.4. So I can say around 70, around 129. So between IQs of 70 and 129, about 95% of the scores fall between those two values. All right, that's all I got. I wanted to keep this one brief, short and sweet.